Now, if we're asked about a modulus question where we have an inequality involved, like if we have y is equal to x minus 1, modulus of x minus 1 less than or equal to 1, what does that mean? It means we are looking for when the y output of our function is less than or equal to 1. So if I draw that in, I'm looking for where my function is less than or equal to y is equal to 1. So what region immediately can I see that that's true for? Well, I can see my dashed line is above my function line, my blue solid line, between x is 0 and x is 2. When is my function less than or equal to 1? It's when my function line is below this dashed line of y is equal to 1. So I can immediately see from my graph that this is going to be true between x is 0 and x is 2. But I won't always be able to draw a graph so easily, or I might not have time, or I might be asked to do it algebraically. So I also need to be able to handle this situation when I can't just draw a graph or a sketch. So generally I would recommend you just square both sides, but you can also do taking the positive or negative. So take x as being, what is inside the modulus could be equal to plus 1, or it could be equal to minus 1, because the modulus of plus or minus 1 is always going to be 1. And here we see that this ends up being quite similar to what we did with squaring, with dealing with our rational modulus. So if I do that, I end up with a quadratic. I know now that I've got a quadratic inequality, I know that I'm going to treat it like a normal inequality and then draw a graph, a sketch, to figure out my range of values. I already know from the graph what it's going to be, but I want to work it out algebraically as though I didn't know. So I'm going to solve here. I want everything over on the left hand side because I'm solving a quadratic. I get x squared minus 2x is equal to 0. And this looks a little bit funny. It's not maybe what I expected, but I know that whenever I'm doing algebra and I'm doing factorizing, trying to solve for something, I'm always going to look for common factor first. And I see I have a common factor of x. So if I keep my head and remember my basics, I'm able to cope. So I have x is equal to 0, or x minus 2 is equal to 0. X is equal to 2. Now I draw a quick sketch. I have a positive quadratic, and I'm looking for roots of 0 and 2. So I know I have a smiley face. I know that it's going to cross the y-axis. I know it's going to cross the y-axis at 0 because there's no constant listed there. So my function is going to look something like that. And I'm looking for this region where it is less than 0. I'm looking for where this is less than 0. So I'm looking for this region down here where the function is below the x-axis, where it is less than 0. So I am looking for the area in between when the blue line is beneath the x-axis, when my y value outputs would be negative, would be less than 0. So I end up with x is going to be greater than 0 and less than or equal to 2, just like I found out from doing my graph. And again, I could also use the method that we used in our previous example here, where I could have taken the answer, or x minus 1 would be equal to plus 1, or x minus 1 would be equal to minus 1, and that would allow me to get the same answers out again. So the graphical method, choosing the plus or minus or squaring both sides, are all valid, and we have to know all three methods and be able to apply them, and we want to be able to spot which one is going to be easier in different contexts. So that's what we need if we have a modulus inequality.